let's go to action now. All right, and in the action, where did everything? Oh, did I didn't write anything, so that's why there is nothing, right? So we have to talk about antiderivatives, right? Everybody clear? So we know derivatives, right? Let me take something really easy. That if I ask you to give me the derivative of sine of x, what would you say it is? Louder? Cosine of x, right? Very nice. So, since the derivative of sine of x is cosine of x, okay, so this is the sign for antiderivative, okay. I like the name indefinite integral better, okay, or just the integral sign better because it's not really anti anything, okay. But anyways, so everybody fine? The derivative of sine x is cosine x. So what we write because of that is this, that the antiderivative of cosine x is what? Sine x, right? Everybody fine? Okay. So what we have is that we can write if we have the derivative of f, and of course f is a function of x, okay. If the derivative of a function of x is this or one sec one, I mean it's not that I did anything wrong, but I just want to go in terms of usual notations. Everybody fine? So if they did, go ahead please.
If it's an indefinite interval, wouldn't it be plus a constant?
That's a very, very good comment. Yes. So antiderivative is sine x. What's your name? Eric. And we are going to incorporate Eric's comment because if we don't, then we'll lose points on the test. Very good. Okay. Very nice. So so here, if the derivative of this function, capital F, which is a differentiable function, of course, if the derivative is small f, then what we say? We say simply that the antiderivative of this is, and we should be grateful to Eric because he suggested, right, that add a constant, okay. And so c is what? C is a constant. And why did we do that? Why did we do that? Because when we differentiate this quantity, right, okay, what will happen? The derivative of the constant will be 0 and still we will get a small fx, right? Everybody good? And Eric, see this here? Here, the computer cheated us. See this here? Look here, I asked computer and see, we have to know what we are doing, right? Otherwise, the computer didn't give us complete answer, right? Okay, so that's a warning against computers. Huh? No, it's not assuming that. It's like it's a very temperamental program. Okay, it's assuming that I know it. Okay, it didn't know that Eric would have to tell me. All right. Anyways, thank you so much. Everybody good? So this is the situation, and I'm not writing all the details. That is, if capital F is a differentiable function, then and all that. These things are assumed in here, and of course, as when Dr. Gavilanes comes back, okay, on Friday, he will go over further details to whichever level of sophistication he wants us to be at. Okay, all right. And as I said, I'll post this transcripts on your MyMC page and a link to this recording on your MyMC page as well. Okay. So everybody fine here? Okay, good. So let's work on these guys here. We have, let me take these in because it'll be easier to type that in there. So we have to work on these guys, right? This one we already did, right? Everybody good? Okay. Now he is asking us for the antiderivative of who? 2x, right? Everybody, everybody fine? So, whose derivative is 2x? Very nice. The derivative of x square is what? 2x, right? And plus a constant, of course. All right. So, if somebody does not give us that number 2, what would you say? Who is this then? Who is this? Well, I don't have a number 2. Now, a property of antiderivatives is this, that is, just like in the case of derivatives, you can factor this constant out. All right? Everybody clear? So if you trust me on this statement, okay, what this will be then? Help? Louder. Yes. Go ahead. Mhm. Yx. See, I know twice to. I want this quantity. That's what. I mean, he wanted us to do this, and I just asked this question, right? Okay, so all that I have to do is what? Louder. Divide it by 2, right? Everybody clear? I was not asking my question very well. So you should be glad I'm not making you quiz, right? Okay. All right. So this is x square, and you can say big C by 2, right? Okay. And then, I mean, you can leave a big C by 2 as big C by 2 or call it a D, right? Everybody fine? Makes sense? Good. Okay. Now, next he wants us to do what? What is the antiderivative of x to the n? All right. Okay. So he wants us to find that. So tell me whose derivative is x to the n. Say I ask you this question. D dx, and here is the question. All right. Or just a moment. Df dx is x to the n. What is f? Tell me, please. Yeah, go ahead. What's your name? Adrian. Yes, sir. Beautiful. Okay. So here, very nice. And I mean, yes, it could be a constant, but this is one of them. Now, in this, yeah, very good. And multiplied by x to the n plus 1. Okay. And of course, plus a constant, because, see, this I had to relate it to x to the n, right? What the derivative does to a constant power, it just reduces it by how much? A 1, right? And the power steps down as a factor. Everybody clear? Okay. So what happens is this, that if I am looking for x to the n as a derivative, and interrupt me anytime, I'm losing you, all right? Okay, you don't have to be just quietly listening to me. So is everybody good on this? Right? Okay. And that's where Adrian got that for us, right? Okay. All right. So what will be an answer to this? X to the antiderivative of x to the n. Oops, sorry about that. Dx is x to the power n plus 1 over who? N plus 1 plus a constant, and here we not times a constant, plus a constant, and we must mention what? That n is not equal to -1, otherwise we will have an illegal denominator, right? Is everybody good so far? Okay, good. All right. Now, next thing is, let me pick up what were the other things he wanted us to do, because my screen is cut off right here. So 1 over x, right? He wanted us to do that. Very good, Eric. All right. All right. Somebody tell me whose derivative is 1 over x. You did it. That of who? So if we differentiate, actually what happens is that even if you write this as ln of absolute value of x, right? Still it is how much? What is it? 1 over x, right? Didn't you do that with the derivative of natural log of absolute value of x is 1 over x, okay? You do it with both the signs, all right? And it turns out to be correct, because for negative numbers, absolute value of x is negative x, right? Okay, everybody fine so far? Okay. So this means somebody help me. Anybody help me? Karen, would you help me, please? Okay, right there. Yeah, I can. Are you a Karen, right? Okay, yeah, just help me. What should I write here? Dx that equals who? Ln of absolute value would be a slightly better, plus an arbitrary constant, right? Everybody fine? Okay. All right. So now think about it, see if you have any questions, and let me do this here. Let me just save this part of the recording quickly. Good. So he's saying that the derivative of big F is small f, right? So the antiderivative of this guy small f will be who? The big F, right? Everybody clear? Does he fill these all like right in front of you, or he fills it partially and asks you to fill the rest at home? I mean, I'll do whatever he does for you. Okay. Tell me how does he work on this? He does the whole thing? Okay. All right. Huh? Do you mind if I do that? He's much younger than me, and I got. It's all right, whichever way. Yeah, I got bad arthritis in my left knee, so I just take advantage of this guy. Okay. Everybody gets again. So, anyways, so here what will happen? Antiderivative of this guy would be what? Then that will be f. Let me raise this prime here, right? Make sense? And this guy c, what will happen? Remember that for uh, antiderivative of x, the way Adrian has helped us out. Very good. We just divide it over by that quantity. Everybody fine so far? Okay, so we will put that. In mathematics, generally, we are sensitive with these symbols. Okay, all right. So, and then of course, we would have what here? Plus a c, right? Makes sense? Everybody good? Okay, so let's quickly write the other things. See, the antiderivative, or this indefinite integral, okay? This respects the addition. That is, if you take the antiderivative of sum of two functions, right? it will be sum of their antiderivatives, right? Question? Oh, one. I don't know. Did I do it wrong? I know. I have no idea, and it will be on record. Oh God, I don't know. And I'll be cheat because I generally don't like to edit things. I made a mistake. I made a mistake, and let it go over. Worst that can happen to me is they may ask me to retire earlier, right? And I can use it. Okay? Good. Thank you so much. What's your name? John. Thanks, John. Very kind of you. And because I hope, Dr. Gavilanes might never think of sending me as a sub again, right? But I don't think he will have time to watch the recording, so I'm safe there, right? Okay, good. So this guy would be what? I'm just erasing this, right? Everybody clear? Good. So at one place I was fooled by the computer and saved by Eric, and in the next one I was saved, from an embarrassment by John. So that's very kind of you guys, right? Okay, good. All right, so that's F plus G and Eric. I think your comment is still Miss Eric left, right? That's okay. And he will know if he watches the recording, right? Okay, that he left. Gloria, help me. What are we missing here, Gloria? We still need a plus a constant, right? Good. Okay, so where are we? We're right here. All right.
Is that always the case, given though it doesn't say in the function?
Particular anti no, right, because what happens is this, in this case, even if you did not write a C, you would not be troubled because it's a particular, you know antiderivative that we are writing. Pierre, you asked me that question, right? Okay. But plus C is like more general. Okay. All right. So even if you forgot to write a C in here, I don't think he's going to be upset. All right. Okay. Good. Very good.
I don't understand why you write plus C like
Say that once again.
I don't understand why it's plus C. Like everything is plus C.
Oh, very good. So see, just go back. What's your name?
Victor?
Victor. Let's just go back to the definition. That is, if a quantity differentiate. Okay. Let me answer it in a better way. See this here? You agreed on this, right? That was no problem, Victor, right? Oh, let me get plus C out here. Okay, that was good, right?
Yeah.
Okay. So what happens is this: you agreed with that because what you have is that you say ddx, right, of x square is 2x, right? So the derivative of x squared is 2x. So the antiderivative of 2x is x squared, right? Now, if I give you this function, x squared plus say 7, who is the antiderivative again? Simply 2x, all right? Okay, so if I add any constant over there, it's not going to matter, right? Okay, makes sense?
Yeah.
Good, very good. Okay, so let's go back to this thing, right? This one we already did, so we just have to do cut and paste, right? Okay, so where is it? We wrote it somewhere, right? Yeah, here. Okay, so we just have to cut and sorry about that. Here you go. Excuse me. So here, I mean, he already wrote n is not equal to -1, okay? But I'm still repeating it. It's good to keep warning signs like, as many places as you want, right? Or as many places as you can put in. What was that for 1 over x? Somebody? Ln of, right? Absolute value of x, right? So x, I'm going to leave it like this because you guys look like a very smart group of people. So let me tell you something that's sometimes very sensitive. When you are working symbolically, keep every symbol looking exactly the same. So instead of, I did not type X in a different font, okay? Make sense? Okay, good. So then, oh, this is my favorite, e to the x. I love this guy. Whose derivative is e to the x? E to the x, right? So that's the easiest one to remember, right? Okay, and if I was making your quiz, I would definitely put that on the quiz because I know everyone would get it right, right? You all will get it right anyways, but the thing is, this one makes sense. What about this? We did this one as well, right? Is sine of x, right? No. And it's not negative sine of x, right? I'm so proud of you all. That is simply sine of x, right? Very nice. And let me just pick, okay, I'll just do this. So this is this. And I think I'm allowed to write sine in a different font. That doesn't matter. That should not matter, but the other one is, and of course, plus a plus C. See, a good thing about this room is this, that we are learning two courses by signing up for one. He's teaching me too. Next door, can you hear him? Right? Oh, sir.
You said C antiderivative of this C.
Just say that once again.
Yeah, scroll a little bit.
I will.
See that function, function,
Uh-huh.
and you said that the derivative was that constant times the antiderivative
Uh-huh.
divided by the derivative.
Oh, no, no, no. Who was that? Yeah, John grilled me on that, remember? Okay. See this here? I have this. Oh, yeah, you were not here. You just temporarily left when that went on. Okay, see this here? This is this, right? Okay, we will bring our constant in a moment, okay? Wait. Just let me finish up. But good, yeah, here. Wait. Now, he wanted us to do this, right? Remember that, Eric? Right? Okay. So, this constant can walk out of the integral sign, right? Okay. So, what will happen when we pull the constant out? What we get? We get this, right? And then that will be what? C times fx, right? Isn't it, right? And if it was big C here, you can leave the same big C here, okay? Very good. Yeah. You're a very good class. I'm so envious. Yeah. I mean, I have good classes too, but the thing is, you're a very good class, right? Everybody fine on this? Okay, let's see what he wants us to do next. Okay, one moment. Okay, just 1 second. Let me save. No, I'm not going to. No, no, I'm okay. Sorry. I mean, we forgot to push that F9 key. So, anyways, where are we? Okay. So he wanted us to get this, right? Everybody clear? So we are integrating this sum. So we did was this to split this sum as two, because just to stay safe for a test purpose. And then Pius asked us to split this as this. I think, and Pius, tell me if I am wrong, because we asked you why did you do that, and you looks like for you it was a natural thing, and which appears to be okay. All right, because he knows that I can take antiderivative of a power, right? We just did it so many times, right? And I'm not writing the constant at the moment, so just forgive me for not being that formal. All right. So he knows I can do that, and if I come across 1 over x, we even know that, right? Everybody good? Okay. So what would I do next then? I have 3, then what? X square plus what? Somebody, anybody help? Help, please. Is that good? Okay, now 3x square. Oh, that's going to be very, very gentle looking, right? Everybody good? When we take, I'm not taking the antiderivative yet. Okay, I just decided to simplify it this way. So this is very good, right? How do I handle the other guy? Somebody, please. Yeah, go ahead. Anybody? Go ahead. Thank you, Eric. All right, he could have asked you to sub, right? Next time I'll suggest him. Okay? All right. Everybody, thank you so much. Very nice. Very good. Because now what happens? We have this matching with this, right? Is everybody good? Okay. So what happens then is that this is very good. So 3x square, right? Plus antiderivative of, and since for many of us we are doing it for the very first time, I'm going very cautiously. All right, and those of you who might have seen it before, it'll be nice to keep some patience with my slow progress here. What do I do here? I pull a 3 out, remember? And I forgot a dx here. I pull a 3 out. Okay. Yeah, we discussed that pretty well a few seconds ago. Okay. And then here we have this. Is everyone fine on every step? Okay. So let's pull this down here. And now we are set. We have 3x square. What do I do with x square? See, this is right here. What do we do with that? Why are you guys so quiet? You don't want to tell me? Very good. We add 1 to the power 3. Very good. And then downstairs also we have what? 3. Good. And what about the other one? Here we will have -1/2, right? And then plus 1, and this is, let me align it a little better. It will do that, but the thing is that looks not very good, well aligned, right? Is that good? Yeah, we've been, and rest is a matter of like simple arithmetic. I don't know why am I writing plus here. Okay, this equals what then? So we have a cubed, and then we have what here? 3, right? And what is this? 1/2. And here also we have what? 1/2, right? Everybody good? So what will happen now is that 3's will cancel, wouldn't they? Right? And 2 will just jump upstairs, won't it? Right? Okay. So this is this right here, and say if we are really symbolically sensitive to what we began with, we can write it like this, right? Everybody good? So this whole quantity is what? Simply this, right? Everybody fine? So what happens is that answer will be what? E to the x, right? Plus these guys, right? And then plus a constant. I mean, we could have gotten constants along all the ways, right? And at the end, we combine them into a big constant. Okay. Okay. Now this time, okay, so we have to do what? That we have to find little f. Let me be a little more formal. You go away from here. Fx, right? If f prime x equals e to the x plus 20 over 1 plus x square, right? And then this time he wants a very particular one, right? That is f0 equals who? Negative 2. Did I copy it correct here? Okay, so let's make more space here. Okay, now Socrates, I have every right to ask you this question now, right? So I have to find this little fx, right? Okay, how would I do that? Its derivative is this, right? So what would you ask me to do, Socrates? Socrates, I mean, say that once again. Very good. We will split the two, and but the thing is, we are splitting the two for the purpose of what? This is the derivative, and we are simply taking what? The antiderivative, right? It's very nice. Good. Very good. Okay. So we got dx here, right? Okay. So then we will split it. Yes, because I mean, even if you don't split it, he won't mind. But this way, if I'm doing it for the first time, it's a good idea to do that, because that way the chances of me making mistakes and losing points go down, right? Okay. So what we have, who is the derivative of e to the x? He's putting e to the x in all of them. That means he will put it on the quiz, right? Okay, so it's e to the x. Very good, because okay, very nice. This one I forgot to pull that 20 out, but you know this is simply 20 times. So let me write it. It doesn't cost me anything. Okay. All right. I just this for the sake of doing it. Okay. So this is this. And what is this? We did it short while ago, right? Remember that? Very good. What's your name? Louder. Akusa? Atusa. Oh, that is it's very close to my name. I'm Atul, so ATU is the same, right? Atusa. Oh, thank you. See? So okay. Everybody fine? And then we have to put a constant at the end, right? So what do we get now? Did I mess up something? Just a second. One moment. One moment. These guys are talking. Good. So yes, somebody was saying something about C, and I forgot in the passage of going here and there. What was that? Okay. So here they want us to give the one, right? for which f at 0 is what? Negative 2. So this time I'll get what? Only 1. Because notice this here. If you graph all these functions, okay, and you all know how to use your calculators for graphing these, right? Okay, so here, let me graph it first. Come on. I can't hear you. Say that again. It is called Scientific Workplace, and if you Google it, all right, so you will know the vendor you can download it from, and if you have a good computer, okay, even with an i3 processor or something, you can download it like within 5 minutes, installs in 5 minutes, and then then you will love it. I love it. And a good thing with this is this, that these guys are very nice, that they don't keep changing it like every 6 months. They change, because when they change it, they really change it for, for better. All right. Like you really notice the change. You see what I mean here? Okay. Because sometimes when the new versions come out, okay, the you see this here, that the time that you have to take to learn the newer version or anything is not really worth the extra money you paid. And I'm not advertising them. They didn't even give it to me for free. All right, I had to buy it. So, but I love it, so I should. So see this here. These are all, like many kinds of answers that could be there, right? Okay, and they want what? They want the answer for which what? F at 0 should be negative 2, right? Everybody clear? Okay, so let's see this here. So we have f of x equals this, sorry, and f at 0 is what? Negative 2, right? So did I copy everything correct? Okay, so we have 0, 0, right? Then 0 again, and that will be C, right? Everybody fine? Am I making sense here?
Yeah.
Yeah. Yeah. Go ahead. Go ahead. Your question?
Oh, no.
No. Just just verifying. Yeah. Very good. You have seen two instances today that you can't just trust me on my words, right? I made two mistakes today, right? Okay. Did I do this right?
Yeah.
What about this? What should I write here? 0. What should I write here? C. So C is what then? Negative 2 minus 1, that is, oops, negative 3, right? So what is the one that they wanted? They wanted this one, right? Everybody fine? Okay. And one thing, let me apologize to you in advance. When you watch the video, you will hear me tapping on the keyboard. I do that hard because generally I have a microphone, attached here, so that sound doesn't go there. So don't. So anyway, whatever. Okay. So just know this. That is. So here we go. Add item. Okay. So let me change the color. Let me make the color green here, just to make sure that we see the solution. It does go through negative 2, and or I can zoom in and see if it's really abiding by or doing what. So what is our solution? A solution that he wanted is the green one, right? Everybody clear? Okay, so let's see. Is the green one going through negative 2? Indeed it is, right? We can just check more. Yes, it is going through negative 2, right? Isn't it? And green one is our solution, right? Okay, let's remove all the other guys because green one is my solution, right? That stays. Okay, good. So everybody fine? And this, this is not a straight line. This is like this. So everything good so far? Okay. So let's go to the next page. At least we finished one page, right? One. Thinking about it. Tell me this first. So we have been taking antiderivatives, right? So if I did this, what would I get? Help. Say that again. F prime, right? What's your name again? Oh, Victor. I'm so sorry. I don't know how I forgot your name so quickly. Okay. Everybody fine? Because the derivative of f prime is f double prime, right? Okay. So we have to find f, and you know what? Oh man. All, okay. No. I thought one of these is a prime. Let me see. I hope it is. Otherwise, we will have too much work to do. No, it's not, right? Does that show prime in any of yours? No? Okay, all right. Okay, that's all right. Whatever, he wanted us to work on it, so we will. Okay? All right. So, excuse me. Let's go on working. Okay? So, this is, well, at least he has given us a good looking function here. Right. Now, since we have gotten a little pro at this, who is the antiderivative of 12x square? That will be 12x cubed over 3. Did I do it right? Yep. Okay, good. Then we got 6x square over, help, 2, then minus 4. What do I write? Plus, excuse me, C, right? Everybody good? Now, I have to find what? Fx, right? Okay, so then we have Sir Alex.
Simplify that before we go to F.
I don't. I wanted to do that. Okay, Pius, you're Pius, right? Okay, Pius, but he didn't give us any condition with derivative here. See? Oh, I see. By simplifying, you mean this. Oh, I know. That looks like, that's very unkind of me to. Because see, the reason I was writing it like this is that I just have to do Control C, Control V. Okay, but I know if I have to write it as very good. Thank you, Pius. Okay. I was thinking he gave us a boundary value problem instead of an initial value problem, but that's all right. We will work on it. Okay, who is this guy? 4x to the 4 over 4 plus 3x to the third over 3. Am I doing it all right so far? Yeah, go. A bit because I'm adding one. Yes, exactly right, Pierre. Pierre, did I say it right? Okay. Minus 4x square over 2. Am I doing it right so far? Plus cx plus what? I will write a d, right? So my fx turns out to be what? This, right? Everybody fine? Now we are going to use. Oh, where did it come? See, when you take the antiderivative of a constant, that will be constant times x, right? Okay, all right. Everybody fine? Good. I told you when you are talking, talk It's okay. No, I'm not asking you to be quiet, but you know that thing is blinking there. Everything is under record. So if you just make sure you don't want the whole world to listen to what you're talking because I don't. Okay. So are we good here? So we have to do now what? F at 0, 0, right? What do I write here? Help. What is this when x is 0? 0, right? I can ask easy questions, right? 0, 0, and 0, right? How much is f0? 4, right? Equals d. Oh, that's a relief, isn't it, right? I like it. So d is how much then? 4, right? Everybody clear? Now, how do I obtain my C? Somebody, anybody, help? How do I obtain C? Yeah, say that again, Atusha. Did I say it right, Atusa? Right, go ahead. F of 1. Very good, Atusa. Very nice. She says, you know f of 1 is 1, so just use it. All right, I'll use it. What do I write here? 1. 1 to the 4 is 1. 1 to the third is 1. 1 square is 1. And this is 1, right? Everybody fine? And f of 1 is 1, right? So 1 equals, what is this then? 1 plus 1. He is very kind, chooses really convenient numbers, right? That's very good. All right, so what do we get then? We get all these guys are out, right? So C is how much? Negative 3, right? Makes sense? So here you go. Have negative 3. Let me very quickly check our answer, okay? I mean, I know I got like about 30 very smart people watching me do this question, okay? So we should have done it right, but let's just make sure that I didn't do anything wrong that the computer didn't catch, okay? What was F0? F0 was 4. Oh yeah, you remembered it right. Yeah, of course you will. And then Y1 is 1. Okay, it wants initial conditions. It won't do that with bound. Don't worry. I think, I mean, I had so many smart people watching me do that, so we should be good, right? Everybody good? Yeah, actually, we could check the answer. It was my mistake because I did this. I gave it a, I didn't put the second order derivative on the left, so I gave it a first order derivative with two boundary conditions. And of course, that's why it did not talk to me, and it would not. And I don't know why I did that. That was the third mistake. Okay, so anyway, let me do this here. Yeah, give it the second order equation. All right, because that's what Dr. Gavilanes did. Okay, and what were his initial conditions? Y0 is 4 and Y1 is 1. So we have Y0 as 4 and Y at 1 as 1. And let's check the answer. Hopefully it will, yeah, it will be nice to us this time, and it is. And I was lazy, didn't cancel 4's here, didn't cancel 3's here. Okay, so it gives us a better looking answer. That is the value of fx is that. That's what, that's the one that we found analytically ourselves. All right. So again, nice to meet you all.